Now that we've looked at regular cash flows, let's look at growing cash flows. Growing cash flows are cash flows which grow at a certain rate. For instance, they can grow at 5%, 10%, and we denote that rate by G, okay, the growth rate. Now let's look at growing annuities. A growing annuity is a stream of n growing cash flows paid at regular intervals. It's a growing perpetuity that eventually comes to an end, okay? So the difference between an annuity and a perpetuity never ends, an annuity does, okay? Now, as you can see, the stream of cash flows now are different because we need to take into account the growth rate, which is why we multiply the cash flows at each period by 1 plus the growth rate, okay? And we can summarize this stream of cash flows by the sum of the cash flows, and so this isn't infinity, the cash flows times their growth rate over the interest rate because we need to discount it, okay? Right. And so the formula for the present value of a growing annuity is the following, okay? So it's the cash flow times 1 over R minus G, open brackets 1 minus, and then the growth rate over the interest rate to the power of n periods, because this is an annuity, okay? So this is the formula that you need to remember, which is crucial. Now let's apply what we know to this exercise. The exercise reads, you work for a pharmaceutical company that has developed a new drug. The patent on the drug will last 17 years, which is how we know this is an annuity and not a perpetuity, because it does come to an end after 17 years. You expect that the drug's profits will be $1 million in its first year, and that this amount will grow at a rate of 5% per year for the next 17 years. Once the patent expires, other pharmaceutical companies will be able to produce the same drug, and competition will likely drive profits to zero. What is the present value of the new drug if the interest rate is 10% per year? Excellent. So we know this is an annuity because it ends after 17 years, and then the company doesn't make any more profit, and therefore we need to use the formula that we looked at before. But before we do that, let's write down the data that we know. So we know that the annuity will last 17 years. So n is 17. Then the cash flows are $1 million. Okay. And then these cash flows grow at a rate of 5%. So G is 5%. And then the interest rate is 10%. So R is 10%. Right. Now let's use the formula, which we said is the present value of the cash flow, so 1 million, times 1 over R minus G. So 10% decimal places 0.1 minus 5%, 0.05. We can put that in brackets. Times, we open brackets, 1 minus, and then we said 1 plus the growth rate. So 1.05 over 1 plus the interest rate, 1.1, to the power of n amount of years, which in this case is 17, and we close brackets. Okay, now we need to solve each bracket first. And if you plug all these numbers into the calculator and calculate it correctly, you should get that the present value of this annuity is equal to $10 million, 930,727.9. So this is the present value of this annuity. And this is how to calculate the present value of a growing annuity.